And welcome to part four, wow, of utility-based decisions. So, where were we when we left off? So we were just doing an elapsed time check so that we could call another function. What we want to do now is we want to evaluate the threats. So what we're going to do is we're going to create a custom event. Actually, before we start this, I should mention that I'm kind of not happy with the way this is all working. I don't know whether you saw it recently, but Mishko did a stream where he showed off some of the EQS work that he's been doing. It's experimentally in 4.6. I think that what we'll probably do is we'll finish this quick kind of utility system, a simple example of it, so maybe another couple of videos, and then I'll upgrade to 4.6 or a more recent version if that's available, and we'll do the utility a little bit better. The thing is that actually I kind of want to build the utility system into the behavior tree editor. Because it's not the right way of doing it right now. So what I'm thinking is that ultimately, maybe over Christmas time, I'll build a system that allows us to have like proper utility in the behavior tree. So what I'm thinking is that we'll have a priority selector. So you imagine there's a whole bunch of simple parallel sequence selector. Well, what I want is a utility selector, I guess, or a priority selector, and then I want the individual sequence nodes to maybe have properties for doing utility-based comparisons, which would mean that essentially we'd be able to have utility for different selection of different actions and actually embed it inside the behavior tree rather than doing it in the controller like we are doing now. So that's a long-term plan. Obviously it'll include some C++ code, and then Mishka's got to sort of say it's okay, and then we've got to get it, put it into the Unreal Engine sort of main code repository. So that's a long-term kind of plan, I think. Certainly at least a few months out. So this is going to get us going as an example, but what I would suggest is this isn't an ideal way of doing it just yet, which is kind of painful, but hey, that's just engine development, I guess. So what we want is we want a custom event. We want to be able to call, so we go to custom event and we call that something like evaluate enemies. So we're going to do that, and it's saved of course, and we're going to do that somewhere else later on. So what we want to do is we want to actually call that event, so call evaluate enemies. So essentially we're just going to call this evaluate enemies event every update frequency elapsed time, so we can change how often this thing runs essentially, which is a good thing for AI in general to be able to do that. So what's this event actually going to do? And here's the kind of interesting bit. Well, it's going to do three things. It's going to calculate a utility score for each threat that we know about. It's going to find the highest utility score from the current sort of scored values, and then it's going to set the highest utility score into the blackboard as the enemy to target. So I usually like to, if I know I'm going to have a few things to do, and even if I don't, I like using sequence blocks, sequence nodes, because that kind of logically works in my programmer brain. It makes it think, makes blueprints a little bit easier to understand. Now then, so to start off with, we're going to do a for each loop. we're going to calculate the utility score for each entry in the threat structure. So we've got this threats array. We're going to drag that into there. We're going to do a for loop. Essentially what we're looking for is we're looking for some kind of score value for each entry in this array. So let's just break that structure apart so we can get the individual parts. I wonder why it comes up with there. It's kind of weird. So we've got a bunch of variables. We're just going to do a fudged version of this right now. So that's the actor that we're evaluating it for. We're going to, there's a thing called set members. We're going to set the members in a structure. The array element is the array element that we're going to use. Actually, we don't care about the array element because we're just going to set it straight in, right? In the for loop. So let's just connect those guys up. I hate the fact that like the lines are all kind of weird. So basically, the array element we're just passing straight into the threat struct. We're going to pass the actor through as per normal. We probably want to update. We'll probably want to update our like last scene time. We're not actually going to use it right now, but let's just do a plus in there. Float plus float. We're going to add our elapsed time to the current time. And we're going to say that's the last scene time. We might change this eventually. Lucky you can't line that up either. So what we actually want to do is we want to calculate this weight value and put it into our threat structure, because ultimately we don't care what the current weight is. We just want to fill in the new weight evaluation. So this is kind of what we're doing. We're coming up with a weight evaluation for each guy. So let's just, for now, let's just go distance. No, I don't like doing that. Let's add a new function. So let's call this distance to actor, and it's going to take an actor as input, object actor, and as output it's going to give us a float. And distance. Did I just spell distance wrong? Yes, I did. The reason why I'm doing this really is just because I want to clean up the sort of interface a little bit, and there are a few nodes that you might use for this. So let's just drag that out. So we want to, in here, get controlled pawn. So the thing that we're controlling, remember this is an AI controller, right? So it's got a controlled pawn that it's controlling. We need to get the position of it, so get nav. And now some of these nodes have changed in later versions, I think. So just be careful that these nodes are here. What we're looking for is the position of the character, essentially. Compared to the guy who we're comparing against, so get actor location. And we're just going to subtract one from the other. So if we just type a minus in there, vector minus vector. And then we want to get the length of that. Length. And that is our distance. Yeah, so it's basically just a simple kind of distance to actor function. But because it has a few of these nodes that we need to use, I decided to to do it as a function rather than just doing it in the graph itself. So going back to the event graph, we can now use that that distance to take off. Why is context sensitive? Change that. Let's just distance to actor. Yeah, you see that? This really is starting to chafe me now. I don't know why. It's like, oh, that's not even the right one. Is it? I did call it a function, didn't I? Okay, so yeah, it's definitely a function. Did we actually save it? Did we compile it? Let's just get rid of that for a second. Did we didn't compile it, that's why. No. So going back to the event graph. Come on. Doc, you damn. Just having a bad day today, aren't I can tell. Oh, of course, I should have docked it in here. Oh, come on. Right, going back to the event graph. Well, that was confusing, wasn't it? Distance to actor. Oh, because it's dragging off. That isn't what I expected. Okay, I'm just going to go and fix this function. And of course, no sooner do I stop recording than I figure out what's the problem, right? So when I did the distance to actor function, I forgot to set it to pure. The reason why I want it to be pure is that I want to just be able to, I changed the name of the actor thing input as well down here. The reason why I want it to be pure is that I'm not actually changing any value inside the function. It's literally just doing a calculation, so I wanted it to be this kind of simple interface rather than having to do the execute pin. So that's why I was kind of fiddling about with that. So if you have a function that doesn't change any internal variables, doesn't change any of the sort of actor variables, it can calculate stuff internally and then just return it. It's basically a pure function, right? So it's just going to return a value. So that's what we're doing. The code's exactly the same as I showed you just then. So what we're going to do now is we're going to get that value, and now we could return that value into the weight, but I actually want to do something a little bit more interesting. Now if we go to our content browser, you can go to miscellaneous and curve and add a curve, and it will, well, let's just do that. It comes up with three different types. Now if you select curve float, it'll bring you up one of these. So I've created one of those and called it threat distance curve, and if I just drag that guy onto here, it allows you to have a curve that you can then edit the values in. So if you see what I've done here, I've basically created a curve that has maximum value of 1 over here, and that comes down to a value of 0 and then maintains 0. And this, if you could think of this as the distance to the object, and this is the sort of threat value. So we could change the curve handles and actually get different shapes of curves and stuff, and edit the curve in general. But what I'm saying is maximum threat when it's very close, and as it gets further away the threat kind of tails off. Now we could maybe do a linear curve, or we could do, you know, a sigmoid function or whatever. I'll refer you to Kevin's talks, and there's a whole bunch of talks on utility based AI. If you look at AI game dev, or if you look at, actually there was an interesting one that I just watched with Kevin Dill. He did an IGDA webinar. It's on YouTube, a 2014 thing, so I'll maybe link it in the description if I remember right when we're uploading. So essentially what we're doing is we're going to use this threat distance curve, and I've added, where are we? Let's just add a threat distance curve to our controller. So we add a variable. It's going to be of type, let's see, struct. I think it's a struct, isn't it? Maybe it's, no, it's not a threat struct, is it? It's no, it's not a class, it's not an interface. I can't remember where it was. Oh, let's just threat distance nope, that's not what we want. We basically want to add a variable of threat distance curve. And of course I can't remember where it was. It's definitely not a class. Element of PRS T. It's what type is it? It's a curve of some sort. It's a curve float, isn't it? That's what it was. Curve float. Yeah, so basically we're adding an object of type curve float. And what you'll see is that if you look at the actual kind of let's just rename that guy threat distance curve. And what we're going to do is we're going to make it public. Actually, we probably should put the threat evaluation. So anyway, go back to the event graph view. So what we're saying is that we're going to evaluate we're going to evaluate it based on the curve. So we get float value. So what this means is that we're using this threat distance curve, and we'll set that up in a minute. Using that curve, we can pass in a value. In this case, we're passing in our distance, and we'll get the floating point value out from that curve. So let's just save that. So that essentially does the very simplified, let's just comment this up, calculate the utility score for each value. Okay, so what's next? We want to find the highest utility score, right? So let's just give ourselves a little bit of room. So one thing we need to do is we need to have an actor, which is the highest threat guy. So let's just add a variable. Let's call this highest threat. It's of type actor. So we want to initially set that to null. So we're basically saying don't select anybody, and then we're going to loop through and look for somebody. The other thing we need is we need a value to say what is the current maximum value for our threat value, right? And that is a float. So let's say float current highest threat. Don't know where that R came from. Yep. So again, we want to set that. We'll set it to 0. So basically we're resetting a couple of variables, and then we're going to do the for each loop again. So for each loop, and our array again is the threats array. Let's just make that a bit cleaner because I'm pedantic about these things. Oh, so annoying that you can't sort those out. So we need to break the threat structure again. What we're looking for is the highest weight. So what we're saying is if our weight is greater than our current highest threat, so let's just do an if branch. So if our weight is higher than our current highest threat, then set our highest threat value. So let's do a set on that. To be the actor. Let's just do that step down a bit. To be the actor that we currently have the weight for, and then we want to set our current highest threat. Basically we're finding the maximum values and storing them. Yeah, so essentially this is, let's just add a comment box, find the highest utility score. Hopefully that makes sense. So we've calculated utility scores for each thing in the array. We've found the highest and stored it in these two variables. And then we just finally need to store that information into our object. So essentially what we're doing is we're doing what we did before, right? We used to set this value as object for the first thing we saw. Now we're storing the things that we see in an array, scoring the array based on some data, and then we're taking the maximum one of that and setting that value as our enemy target. So let's just finally comment that bit. Set the highest utility score threat as our current target. Yeah, so that's basically the three kind of things we need to do when we're evaluating threats. So I think we'll have a quick break there, and then in the next video we'll look at how this works, maybe look at adding a better utility function, because obviously the distance to the threat isn't the only thing we should be thinking of. Let's just space those out a little bit. Let's just, should I comment that? Yeah, why not? Let's just, alright, 3 steps. Okay, so why does it always error out when it says that? It's crazy. Right. Okay, let's take a quick pause. I'll go and have a cup of tea, and then we'll come back and see if that works. I'll probably do that in the next video, because I think this one's getting a little bit long again. I'm going to try and break these things down into a slightly smaller section so I can edit it easier. Just remember, this threat curve function thing is actually a really nice kind of use for curves in general. If you're going to make decisions, you often don't want them to be Boolean, and that's my problem with the behavior trees currently, is that all of the sort of decision making is true or false, and often decisions aren't quite true or false. They're kind of multi-dimensional, often kind of vague floating point notions, and I want to build that into our behavior tree architecture to have less just true false decision making. So I'm going to have a think about that over Christmas, I think, and see if I can contribute to the code so we can do some of these things a little bit more modularly in a behavior tree. Okay, that's it for now. I shall be back with another video shortly. Oh, by the way, I'm sorry it takes so long to get to this next few videos from the ones I did before, but obviously my work kind of impinges on the time I've got available. I had a whole bunch of students submitting some work, so it's kind of like, you know, everybody melts down in the last couple of weeks of working before they got an assignment due. So we should have quite a few more videos coming up over Christmas time, because I'll obviously be off work then. So I'll post a whole bunch of videos for all sorts of stuff, not just AI, I think. But anyway, I'll see you in the next one.